Greetings to all dear students. So in this video, we are going to see the examples related to harmonic functions. Okay. So before that, we are left with the Milne-Thompson method. First, I will explain what is Milne-Thompson method, and then we move on to the examples. Okay. So Milne-Thompson method. Actually, this method is used to find the analytic function with the help of real part or imaginary part. Okay. So let u of x comma y be a given harmonic functions. So they have given the real part of an analytic function which we need to find. Okay. So let u of x comma y be a given harmonic function. So the given function must be the real part or imaginary part must be a harmonic function first. So, and then let f of z is equal to u of x comma y plus I into v of x comma y be an analytic function. So, this is the function we are going to find. Then f dash of z, suppose f of z equal to in this form, then f dash of z equal to different, already we know the formula for f dash of z, we studied in the first theorem. That is f dash of z equal to ux plus ivx or vy plus iuy something. So f dash of z equal to ux plus ivx. So ux of x comma y plus ivx of x comma y. So here we are using the Cauchy-Riemann equation in the place Vx. Okay. So in the place Vx, we are replacing Vx as minus Uy using CR equation. So therefore, now f dash of z equal to Ux minus Iuy. Okay. Now we are letting the function Ux of x comma y as pi1 of x comma y and uy of x comma y as pi2 of x comma y. Okay, so far what we have done is they have given a harmonic function u, and then we take f of z as the analytic function which we are going to find. Then the derivative of f of z can be written as ux plus ivx. In the place of ivx, we are using by using CR equation, we replace vx by minus uy. Okay, so now we are taking ux of x comma y as pi1 of x comma y and uy of x comma y as pi2 of x comma y. Okay, next. Okay, we know that x can be written as z plus z bar by 2 and y can be written as z minus z bar by 2y. We already know this one because if z equal to x plus iy, then yeah, we know that this already. X plus iy is equal to z and x minus iy is equal to z bar. If we need the value x, then we have to add these two equations. If we need the value y, then we need to subtract these two equations. We get x as z plus z bar by 2 and y as z minus z bar by 2i. Okay, so now, okay, now substitute the value of x and y in the place f1 now, f dash of z. Okay, so in the place of x and y, we are rewriting, we rewrite the x and y with z plus z bar by 2 and z minus z bar by 2y. So therefore, f dash of z equal to pi1 of, because we were taken ux of x comma y as pi1 of x comma y. So therefore, pi1 of z plus z bar by 2 comma z minus z bar by 2i minus I pi2 of z plus z bar by 2 comma z minus z bar by 2i. Now putting z equal to z bar, okay, we get f dash of z equal to z equal to z bar means it will become 2z by 2. So 2 cancel z. Here we get z minus z. Therefore, this term will become 0. And similarly, here this will become z and this will become 0. So therefore, f dash of z equal to pi 1 of z comma 0 minus I pi 2 of z comma 0. Okay. Okay. So if f dash of z equal to this means I need the function f of z only, isn't it? So we need to find the function and analytic function f of z. But here we have obtained f dash of z. So if I need f of z means what we have to do? We have to integral the above equation. That is, we have to integral this equation. So if we integral this equation, we get f of z. The required analytic function f of z equal to integral over pi 1 of z comma 0 minus I pi 2 of z comma 0 into dz plus 1 constant. Okay. So it's a simple method. So what you need to do is they will give given real part or imaginary part of an analytic function. First, we need to check whether the given function is analytic. First, we need to check whether the given function is analytic and then write the f of z as ux of x comma y plus I into v of x comma y, and then take derivative using the formula, derivative formula we get ux plus ivx. In the place of vx, we are replacing vx by uy using CR equation, and then we take ux of x comma y as pi 1 of x comma y and uy of x comma y as pi 2 of x comma y. So next we are replacing x and y with z plus z bar. That is x equal to z plus z bar by 2 and y equal to z minus z bar by 2. So in the place of x and y, we are replacing as x z plus z bar by 2 and z minus z bar by 2. So therefore, f dash of z becomes pi 1 of this and minus I pi 2 of this. Next, we are replacing z bar as z. So if we put z bar as z, then this will become z and this will become 0. Similarly, this term will become z and this will become 0. So therefore, we get f dash of z equal to pi 1 of z comma 0 minus I pi 2 of z comma 0. So therefore, if f dash of z equal to this means f of z can be obtained by integrating the above equation. Therefore, f of z equal to integral over this plus 1 constant. So this is the required analytic function. Okay. So here they have given the real part of the analytic function. Suppose if they are given the imaginary part of the analytic function, then by similar method we can obtain f of z as pi 1 of psi 1 of z comma 0 plus I psi 2 of z comma 0 plus z, where psi 1 of x comma y is equal to vy and psi 2 of x comma y is equal to vx. Okay. So that is, here we have taken since the imaginary wait a minute. Okay, since the real part is given, we have taken the formula for f dash of z with the ux plus ivx, and we are replacing vx as uy. Suppose if they given the imaginary part, then you have to replace ux as vy. Okay, so vx will be vx and the ux will become vy. Okay, so if u given, then we have to change the formula f dash of z with the ux uy. So if they given the imaginary part, then we have to change the formula f dash of z as vx and vy. That's all. Okay, so next we will see the problems related to harmonic functions. Okay, so they are all very easy problems only. So first problem, prove that the function u is equal to 2x minus x cube plus 3xy square is harmonic. So they have given the real part of the function and they asked to check whether the given, not check, they have to ask to prove the function u is harmonic and find its harmonic conjugate. Okay, so first things to prove the given function is harmonic, next thing to find the harmonic conjugate of the given function, and the third one is also find the corresponding analytic function. So either you can apply Milne-Thompson method or the previous method. What is the previous method? This one. Okay. So they have given, okay, if you see the example, then you may remember this one. So they have given the real part of an analytic function. First we check whether, whether this function is harmonic. Yes, it is harmonic function. Then using CR equation, we write this dou v by dou x equal to minus dou u by dou y is equal to minus 2y and dou v by dou y is equal to dou u by dou x equal to 2x. So we have obtained two equation in V, okay, in so dou v by dou x equal to minus 2y, dou v by dou y is equal to 2x. Next, choose any one of the equation, then integrate with respect to, if you choose the equation first, then you have to integrate with respect to x. If you choose the second equation, then you have to integrate with respect to y. So we have choose the second equation, so therefore we are integrating with respect to y. So we obtain the function v is equal to 2xy plus pi of x. As I already told, if we are integrating with respect to y, then we are taking as pi of x is a function of x alone. Suppose if we are integrating with respect to x, then we have to take it as pi of y is a function of y alone. Okay, so next our aim is to find the value of pi of x. Okay, next our aim is to find the value of pi of x. For that, we are as we have used this one, so next we are going to use not this one, the form Vx. Okay, so V is given, so we are from this we are finding the value dou v by dou x, which is equal to 2y plus pi dash of x. Okay, so already we know that dou v by dou x equal to minus dou u by dou y. Okay, so dou v by dou x equal to, using CR equation, we know this one, dou v by dou x equal to minus dou u by dou y. But what is dou u by dou y? So dou u by dou y is equal to, from this dou u by dou u by dou y is equal to minus 2y. Okay, substitute the value of minus 2y in this place. Okay, substitute the value of minus 2y in this place. We get dou v by dou x equal to dou v by dou x equal to 2y. So already okay. Already we have one Vx here to one Vx. So comparing these two, we get 2y plus pi dash of, okay, 2y plus pi dash of x equal to 2y. So 2y will get cancelled, therefore pi dash of x equal to 0, which means pi of x equal to, pi of x must be a constant one. So substitute the value of pi of x, substitute the value of pi of x in the place here. Okay, so substitute the value of pi of x in the place here. So we obtain v is equal to 2xy plus c. So already we have the function u. Now we obtain the function v. So therefore f of z equal to, okay, u of x comma y plus I into v of x comma y. Substitute the value of u and v here and we change it in the z form. Therefore, f of z equal to z square plus ic. So this is the required analytic function. So this is one method and the Milne-Thompson method is the another method. So which way you're comfortable, you can use that one, okay? When they given the simple, simple function, you can follow the first method. If they given the hardest function, that is u in the real part or imaginary part involves very tedious differentiation, then you can go with the Milne-Thompson method, okay? Okay. So, okay. Next we see the problem number 1. Prove that the function u is equal to 2x minus x cube plus 3xy square is harmonic and find its harmonic conjugate. So also find the corresponding analytic function. So the three things we need to prove here. First one, u is harmonic, the given function is harmonic. And then second, we need to find the harmonic conjugate of u. And the third one is analytic function. So what is harmonic conjugate of u? We know that if w is equal to, sorry, if z equal to x plus x, u plus iv, then v is the harmonic conjugate of u. So we need to find the imaginary part of the given function and then we find the analytic function. So there are three things we need to find here. So first we check whether the given function is harmonic or not. Okay. Okay. So to prove u is equal to 2x minus x cube plus 3xy square is a harmonic function. So to prove that the given function is harmonic function, what we have to do? We have to check dou square u by dou x square plus dou square u by dou y square equal to 0. So in other words, u x x plus u y y equal to 0. Okay. So therefore, okay, first let me remove this one. So therefore, ux equal to differentiating u with respect to x, we get 2 minus 3x square plus 3y square. When we again differentiate this, we get u xx equal to minus 6x. When we derive the function u with respect to y, we get 6xy. When we again differentiating, we get 6x. So therefore, dou square u by dou x square plus dou square u by dou y square is equal to minus 6x plus 6x is equal to 0. Therefore, this function satisfies the condition for a harmonic function. So therefore, the given function u is a harmonic function. So first part is over. What is the second one? We need to find a harmonic conjugate of the given function. That is, we have to find the imaginary part of the given function. So here you can either use the Milne-Thompson method or the first method. Okay. So here they have used the first method. Okay. So next we shall find the harmonic conjugate of u. By using CR equation, we have, okay, the first method, we have to use the CR equation. So using CR equation, we get dou v by dou y is equal to, okay, I will write here. First, we will find dou v by dou x and dou v by dou y. Okay, so if you are going to use this one, then you can use this one. If you are going to use this part, then you can this one. So here we are going to use this part, dou v by dou y. So for that, we find the value of dou v by dou y. But what is dou v by dou y? It is equal to dou u by dou x. Since u is given, we are finding the value of dou v by dou y in with the help of u. So dou v by dou y is equal to dou u by dou x is equal to 2 minus 3x square plus 3y square. So now what we need to do, we have to integrate the equation with respect to y. So when we integrate this function with respect to y, we get integral over dou v by dou y is equal to integral over 2 minus 3x square plus 3y square into dy. Okay. So therefore we get b is equal to 2y minus 3x square y plus differentiating y square, integrating y square is equal to y cube by 3. 3 will get cancelled. So y cube we get plus, since we are integrating with respect to y, we get pi of x, where pi of x is an arbitrary function of x. Okay. So next our aim is to find the value of pi of x. So next our aim is to find the value of pi of x. For that, what we have to do? We have to differentiate this v with respect to x. Okay, so we need to differentiate v with respect to x, and then using CR equation, we have dou v by dou x equal to minus dou u by dou y. Okay, so dou v by dou x equal to minus dou u by dou y. So from the given function u, we can find the value of dou u by dou y. And then when we substitute the value of dou u by dou y, we get the value of dou v by dou x. So comparing dou v by dou x obtained from using CR equation and using the function v. Okay. So this value is obtained from differentiating this function. Okay, so this value is obtained from differentiating the function v with respect to x. This value is obtained from differentiating the given function. Okay, this value is obtained from differentiating the given function. Okay, so comparing the equation 2 and 3. So comparing the equation 2 and 3, we get minus 6xy plus pi dash of x equal to minus 6y. So from this, pi dash of x equal to 0. So the pi of x must be a constant 1. Okay, pi of x must be a constant 1. So we are substituting the value of pi of x as c in the equation. Which equation? This equation number 1. Okay, so in this place, we are replacing pi of x as c. So therefore, we obtain the imaginary part, that is harmonic conjugate of the given function as v is equal to 2y minus 3x square y plus y cube plus c. Okay, so now the required analytic function is f of z equal to u of x comma y plus I into v of x comma y. Substitute the value of u and v in the respective place. So we get 2x minus x cube plus 3xy square plus I into 2y minus 3x square y plus y cube plus c. Next, we are combining the of one which terms 2x and I 2y, that is 2x and 2iy. Then x cube 3x y square, this term. We are comparing these 4 terms plus ic. Here 2 is common, so we get 2 into x plus iy. This is equal to x plus iy the whole cube. Okay, so what is the formula for a plus b the whole cube is equal to a cube. So for x cube. plus 3ab square. So first term is x cube. The second term is 3ab square. So put 3 a is x, b square. B square is iy the whole square. So iy the whole square is equal to minus y square. So we have minus 3xy square. The third term is 3a square b. So 3a square. A square is x square, b is iy. So 3ix square y. The fourth term is plus b cube. So b cube is a iy the whole cube. Iy the whole cube can be written as I square into I. That is I the whole cube written as I square into I. I square is equal to minus 1. Therefore, we get minus iy cube. So this four terms is equal to x plus iy the whole cube. We know that x plus iy is equal to z. Therefore, f of z is equal to 2z minus z cube plus iz is the required analytic function. Okay. So very easy problem. With the help of given harmonic function, we are finding the conjugate, harmonic conjugate of the function, and then we find the what? Analytic function. Okay. So to find the harmonic conjugate, either you have to choose Vx or Vy. Okay. So using CR equation, we can find the value of Vx or Vy. So either you can choose Vx or Vy. If you choose Vx, then we integrate with respect to x. If you choose y, then integrate with respect to y. And then find the value of v. So here we obtain either pi of x or pi of y. In order to find the value of pi of x, we are using the other one. If you use Vx, then you have to use Vy to find the value of pi of x, pi of y. If you use Vy, then you have to use Vx to find the value for pi of y. Okay. So I hope this problem is clear to you all. So if you have any doubt, then you can contact me over the phone or message or in person. Okay. So in the following video, we will see problems 2 and so on. Okay. Thank you, my dear students.